Hello everyone. Today's video is about repairing a boot lock actuator. So this is the actuator from a boot lock. It's from a Renault Megane, and it operates when this little motor turns and pushes this out. But this cog here is stripped just in that point. So I want to make a new one of these. There's a spiral here. That spiral pushes this thing out. So I need to make a thing with a spiral like that. So this is the CAD drawing that I've done of the little spiral. So let's see what we can do if we CNC it. So there we have it. This is just a prototype. A little stopper at the top here. And in there, there's a little wedge where it goes up against. Somehow I need to hold this in the chuck while I turn the teeth, while I cut the teeth on here. I think I'm going to have to make something that I can bolt this onto or screw this onto. Okay, so 2.5mm hole, an M3 thread, okay, so I've screwed the screw through this part. And then we're going to screw it into that boss. That is a nice solid piece for that thing to hold against. I must just cut this back a little bit so that when I cut the threads, when I cut the teeth, it doesn't go into this. Okay, I think I'm ready. Okay, so here's my indexer. Here's the little boss we made. and I'm thinking that this little V-bit, when I put it into those teeth of the cog, it appears that this is exactly the right shape. So we'll do a test and just see how it works. Okay, so we've got the middle that way. Turns. So on my chart here, it's 40 teeth. So it is saying I've got to be on the hole 32. And then it's one complete turn and 16 holes. Complete turn and 16 holes. So first of all, let's just find which one is 32. Okay, 32 is right on the inside. It's the very inner one. So this thing is not cutting cleanly and it's spun. So I think I'm going to have to make like a locating hole to pin it on there so that it's locked in place. Okay, so there you can see I've got the little extra screw in there. That's going to hold it tight. Right, let's go. It's a little furry. I'm just going to clean it up with a blade. So there's the block of brass I'm going to use. Okay, so that's nicely flat on both sides. Let's see if we can cut it out. Okay, let's get that to the middle. took ages cutting this thing out in the brass, and in retrospect I should have done most of the machining in the lathe and just left the tricky bits to the CNC. So there's the piece ready to go. I just need to make a little pass at the back. As this one has got, you can see there's like a little raised portion in the middle and a hole. So I'm going to do that now. Okay, so I've got that flat, looks like. I think we've got it. It's got like that little nib on there with a hole in. I'm leaving the outer edge where it is because on the arbor that I'm bolting this onto, I want a flat surface. So that's what it's looking like at the moment. Now I think it's time to cut the teeth. Okay, so I've got a 3mm thread inside that hole. So this is not working. As you can see, this thing is way out. So this is within 0.1 of a millimeter, the actual arbor. These other things are like a millimeter or more out. Okay, so what I've done, I've put the 4-jaw chuck on here and I've centered this thing now, so it's within 0.1 of a millimeter. I mean, the surface is quite rough anyway. This axle in the middle has not come out very well with the CNC. I think the brass was just too much for the machine. But this is now centralized. So fortunately the thread on my indexer is the same, it's got the same chuck thread as the lathe. So I can screw this whole chuck off now that it's centered and put it onto my indexer. There's the indexer. So if I can get this off and screw the 4-jaw chuck on, okay, I think we're in business. So I've set you up on the opposite side now. So I can work from here. Okay, that's just touching on there. I'm going to set my Z to 0, and now I'll go down 1.5. Okay, so I've taken this bit out because it's kind of, it looks like it's flattish on the bottom. So it's not nice, it's not a nice cut. And I've got this cutter, which is brand new, which goes to a really good point. So I'm going to put this one in here. And I said I'm going to go down 1. So let's see what 1 does. 1.5. One and half. Okay, so that's what it looks like. I've taken it out of the thingy now, but now I have to cut this back section off. So I've got a little piece of aluminium. What the hell's going on here? Just need to shave off this extra bit here. I'm going to go very gently. Okay, that's as good as it's going to get. I'm going to just go around and deburr everything. Okay, I'm going to put a piece of this in the chuck, and I'm going to turn the little pin so the top of this has got like a little pin that sticks out. Three mil tap. Okay, so what I'm going to do here, I've got a little 3mm thread that's going into that shaft, and then I'm going to screw that into there, like that. So I'm going to just check this for fitment, and if it's right, I'm going to put a dot of Loctite on and lock those threads in place. That is it. It was at this stage that I realized that the original gear has a little stopper at each end of the spiral, and that holds the pin in place when the motor is de-energized. So it's back to the drawing board, and here you can see I've modified my CNC file to put these two little nibs onto the spiral, and I've also decided to make the next gear out of plastic. So let's see how that goes. Okay. There's a block of this stuff. Let's get it in here. Okay. Now I have to make, let's see, this little raised part there. Okay, so we've got that little piece. Now I'm going to turn the diameter of this. 5 should be. This is where I realize I've overshot the measurement and cut too deep. So no matter how many times I measure it, it's still too deep. So at this point, I'm pondering what to do. I've gone too small. Turn it around, start over on the side. Okay, so we back to this point again. We have the diameter correct. We've got the little boss at the bottom, and we've got a little divot in there. Now we flip it over, and on this side we're going to turn this shaft. The beauty of this now is that everything is properly concentric around that center hole. Okay. I'm going to cut a thread. So I've cut it as deep as I can with this, but it is plastic, so I'm going to just see if I can screw a screw through. So I've cut this hole out, which is just fractionally smaller than this one, so it's like a real hard push fit. There's a washer, will fit at the bottom. Okay. Well, I finished machining this whole one, and once I pulled it out, I realized that the cog was too thin because I hadn't pushed the workpiece down deep enough. And together with the top of the axle being cut off, I discarded it and I started again. Okay, so I've got this set up again on here. So as you can see, let me get something to point with. There's a screw there, and it's screwed into the center. And that little screw should stop it turning. So here's my chart. I'm going to do 40 teeth, so it's on circle 32, 1 full turn and 16 holes. 16 is half of 32. So it's essentially 1.5 turns per tooth. Okay, so there we are, just on the surface. I'm going to set the DRO to 0. Move this out of the way. And go down 1.5 mils. Okay, that's it. A little spacer washer, because this is a little proud boss at the bottom. Well, you're not going to believe it, but the one I just finished machining was no good. The little nibs that we put in were not working with this plastic because this plastic is quite hard. So I'm back onto the next one, number 3. So just to show the evolution of what I was doing, in the beginning I made a few prototypes to get the spiral correct. Then I went on to checking if the teeth were right, and then I made the first one out of brass, and that was relatively successful. So then I made a new prototype. So this prototype, you can see I put a little nib on there and a little nib on there, and I cut a relief behind it so that so there's a little bit of give with the plastic. The pin can clip in at this side and go around and can clip in on this side. So this is the first one, and I found that this nib was just too big. So then I made this one. And this one I cut it right through so that I could observe how the pin was working. And again, I had a little nib, but it's a bit smaller on either side, and I still had the relief. And this sort of worked, but it was quite tight. So then I made another one, and I made this little nib much smaller so that it just catches. So after I made that, I said, okay, now I'm ready, and I went and I got some decent plastic, hard plastic to make it out of, because this blue plastic is just an old cutting board, so it's not really very nice plastic. So this is a proper PTFE plastic, so it's nice and hard. So this was my next one that I made, and while I was busy making this one, I kind of messed it up. I didn't leave enough space for the CNC machine to, it's called the safe height, and the safe height ground the top of the pin off. So then I made this one. So this one is now, it's got the teeth, it's got the little protrusions on either side, it's got the clearance in it, and all was fine, except again I messed up with the CNC and I cut a little bit too deep here, and it's right at the point where the pin goes in, and it was getting hooked on this little corner. So to test that it was all working, I put some epoxy in there and molded it to see if it works, and it worked with the epoxy. So that was that one. And then, from learning all of those things, I turned this final one. So we've got two working ones. We've got the brass one which works, and we've got this one that works. I'm going to put this in here. So there it sits in, it sits flush. And I'm going to bring 220 volts on, 12 volts on it. It goes that way. The little red dots shows that it's at its furthest point, and then it comes back. So just to show you the brass gear, so that brings me to the end of this video. Wow, how many mistakes can one make in one project? Obviously this project would not be a cost-effective project to do, but it was a challenge and it was quite fun. And I need to say thanks for watching, and please join me on the next one.